today is the 7.1 notes on scatter diagrams. The objective, students will be able to plot a scatter diagram and determine correlation of a given data set. So we're going to start with a definition. All right, bivariate data analysis is the study of the relationship between two data sets. Bivariate data analysis is the study of the relationship between two data sets. So let's take a look. In example 1, the height and corresponding weight of 10 students are shown in the table below. So the top row is the height in centimeters, and the bottom row is the weight in kilograms. So the United States is one of the few countries that uses what's called the standard units of measure, but everywhere else is using the metric system. So this is metric. It says plot a scatter diagram, or sometimes it's called a scatter plot, to represent the data gathered for the 10 students. All right, so let's do this. All right, so take a look at, we're going to put the heights on the x-axis, and that's in centimeter, and we're going to put the weight in kilograms on the y-axis. So let's look at those heights. The smallest one I see is 155, so instead of this being 0, I'm going to call it 154. And I'm going to go by 2s. I think that'll do the job. And then let's look at the weights. The smallest weight I see is 60. I don't think it went above 90. Okay. All right. So a scatter plot just means you are literally going to plot dots here. Okay. So I have 182 is up to 90. 155 is at 60. 174 is 84. 166 is 73, 158 is 68, 171 is 77, 179 is 84. Whoops, let me undo that one. It would be the same as this one, right? Yep, there we go. 180 is at 86, 168 is 74, okay, and 160 is 73. That would be up here. Okay. So in general, I guess what I can see here, if I wanted to kind of summarize what I'm seeing, as height increases, weight also increases. So the purpose of plotting a scatter diagram or a scatter plot is to look and analyze the information. Okay, so it does look like a general trend is as height increases, the weight increases. All right, a correlation exists between two variables x and y when a change in x corresponds to a change in y. So this is called correlation. And in the next lesson, we're going to do a little further digging into correlation. But in this one here, okay, a general upward trend shows a positive correlation. So really it's like slope, okay? So a positive correlation. Y increases as X increases. Here we have a negative correlation because as X increases, Y decreases. This one here, these points are all over the place. And so we would say no trend may indicate little or no correlation. This suggests there is no correlation or very weak one between the two variables. Note, a scatter diagram not only shows you whether the correlation between two variables is positive or negative, but it can also tell you about the strength of the correlation. The stronger the correlation, the more the points will look like a straight line. All right, the three graphs on the next page all show variables which have positive linear correlation, but each has a different strength. So the one on my left is a very strong positive correlation. Do you see how close it fits to a line? This would be moderate. You can still see it's positive. And this one is very weak, very weak. We will well define this again in the next lesson. All right, using the data below, okay, so what I want you to look at here is the bottom is fresh lemons imported to the U.S. from Mexico. So 300 metric tons, 350, up to 600 metric tons. And then here's the total U.S. highway fatality rate. So using this data, you could try to argue that the more lemons imported into the U.S. from Mexico, the fewer the road fatalities. However, we know that actually makes no sense because it's clear the number of lemons do not cause a decrease in the fatality rate. But there is what we call a chance correlation between the data sets. You sometimes need to be aware of these chance correlations when analyzing claims made as a result of misinterpretation of statistics. This is also to help you as you begin work on your internal assessment. Just because you can force a graph, it doesn't mean there's actually a correlation here, okay? All right, so this was a short one